Next, we look at sieving. Sieving is what we even use at home. We make use of what we call sieve. That is that substance that we have a kind of mesh like this. Are you there? Like sieve like this. So let me just tell us, what is it used for? Sieving, let me just say, sieving is used to separate solids of different sizes. Solids of what? Different sizes. Yeah, that's what it's used for. Okay, this word different or distinct is the key word in defining what sieving. Are we together? Good. Now, the type of, you see, if you want to obtain solid of a particular size, we make use of this sieve. Now, the type of solid that will be coming outside of the sieve will be solids of, like, that has the size of the hole that you're having in this sieve. Are we together? I believe every one of us will have this sieve, so it will be easier for us to understand. Okay, so it's used to obtain solids of some particular size that you need. So that's what sieving is used for, and it is used using this apparatus called sieve, and that's all. Now, let's commence. So let's look at sublimation and magnetization. So sublimation is used to separate sublime solid from other solid that cannot sublime. Like our usual way, let's explain the keywords there. What meaning of sublime? What meaning of sublimation? You see, there are some solid that can never exist as liquid. There are some solid that can never exist as liquid. If you apply heat to them, they will turn directly to vapor. Remember, from solid to gas directly is what we call sublimation. If you look at, when we study the changes of state of matter, you see that if you have solid, if you have liquid, pay attention, and if you have gas, remember, from solid to liquid, I will have to melt. That's melting. From liquid to gas, that's what? Evaporation. Are you there? Evaporation, can put boiling. From gas to liquid is what? From gas to liquid is condensation. And from liquid to solid is what? Freezing. Look at this state. You can see the way it is. But if I go from solid directly to gas, that is what? Solid to gas directly is what we call what? We call it sublimation. Do you see that? Sublimation. Okay, so the process whereby solid changes directly to gas without passing through the liquid state is what we call sublimation. So solid that don't exist as liquid, they are called sublime solids. Example: naphthalene, ammonium chloride, iodine, sulfur, dry ice. All these don't exist as liquid, they will go directly to gas. So how do we separate them? Okay, let me say, if they ask you what can you use to separate a mixture of sodium chloride and, let me say, iodine crystals, what will you use? Sodium chloride doesn't sublime, but this one can sublime, so the mixture should be poured here. Then when you apply it, what happens? That one that can sublime will quickly change from this solid to vapor. You see this black thing you see here is cotton wool. Cotton wool, yeah. So when it moves directly here to vapor, when it gets to this side, it become cooled and turn back to solid again. Remember, it doesn't go to liquid. From solid, it goes here directly and become a gas, and it is being trapped. You see, we use this cotton wool to trap it so that it won't escape from this funnel. You see, this is a funnel. This is a funnel, but the funnel is what? Is inverted. So inverted funnel. Are you there? That's it. So when you eat them, it becomes solid. It is being trapped at this what? At this cotton wool, and that's just the principle. Next, we look at what? Magnetization. From the word magnet, we use it to separate magnetic substance from other substance that does not attract a magnet. What do we use there? We make use of what? Of a magnet. Any type of magnet, bar magnet, or any other one, you know. Good. So that is it. So how can I separate ion filings? How can I separate ion filings and let me say any other solid material and any other solid like, let me say, plastic. Are you there? And plastics. So what we use was magnetization, because magnets can attract ion filings, cannot attract this. So we use what? Magnetization, and that's that for that.